Here's our essential question. How can I prove that two shapes are similar? We've learned a lot about similar shapes being the same shape but a different size. We've learned about dilations, how to transform things in a coordinate grid. Now let's look at the three ways that we need to know, class, how to prove that two shapes are similar. Number one, the first way that we can do that is, if a shape is dilated using a center of dilation and a scale factor, then we know the shapes are similar. If you can prove that a shape, a preimage, has been dilated using a center of dilation and a scale factor, then automatically you can say, therefore, you know they are similar. Let's label some things here in our proof. So you want to know, okay, are these two shapes similar? Well, here's what we would have to know to do so. One, they have a center of dilation. I'm going to put COD here, and I'm going to label that as D. So I already know they have a center of dilation, so that part's done. Now I just have to figure out is, do they have the same scale factor? And the way we could prove that is, we'd have to actually get some measurements here. Let's label these as our, let's just call this first one the preimage. We don't know which is which. Doesn't matter actually for proving whether they're similar or not. And so here's what we'd have to prove. We'd have to prove that they have the same scale factor, and that means we'd have to find if this statement is true or not. If we can prove that dA prime divided by dA is equal to dB prime divided by dB, and that's equal to dC prime over dC. If we can prove that our distances from our center of dilation to corresponding vertices on the two shapes have the same ratio, then we're proving that we have the same scale factor. So if we can show that this statement is true, then we have a scale factor. We have a scale factor that maps. When we say maps, it means that copies, so that maps triangle ABC to triangle A prime, B prime, C prime. So here's our proof. If I can show that two shapes have a COD, and they do, and I can show that the distances to the corresponding vertices have the exact same ratio, then that proves to me that we have a scale factor, and that scale factor and that COD together proves to us that those two shapes are similar. Let's look at an example of that. So here's a question, are these two shapes similar? And they give us some measurements. Well, the first thing we notice is there is a COD. So that means the first thing passes our test. These two shapes have a COD, so far so good. If we can prove that these vertices have the same scale factor to the COD, then we can prove they're similar. So let's take a look. We have to check, does CD prime over CD equal CE prime over CE, and does that equal CF prime over CF? So I'm looking at the distance from the COD, which I labeled as point C, to D prime as a ratio of C over C to D. So the distance to for the image compared to the preimage, doesn't really matter which way you go on that, it'll work both ways. Well, let's find out. Does this proportional statement hold true? Let's find out. Well, let's do our numbers. So CD prime is 5 and CD is 10, and that's supposed to equal CE prime, which is 8, over CE, which is 14, and that's supposed to equal CF prime, which is 4, over CF, which is 8. Let's go ahead and put these in our calculator. 5 divided by 10 is 0.5. Okay, 8 divided by 14, let's check that out. Okay, 8 divided by 14, let's go ahead and check that out. 8 divided by 14 equals, okay, that's 0.571. Let's just round it to 0.57. We already see we have an issue. 0.57. And 4 divided by 8 is also 0.5. Well, here's our problem. Our proportionality statement is not true. The ratio of the distance from the COD to the corresponding vertices, they're not all the same ratio. So because of this, I'm going to circle this. And that means the answer is no. They are not similar. In order to be similar, remember, they'd have to have a COD, which we had, but we would also have to have proportionality, or the same scale factor between corresponding distances from the COD to the corresponding vertices. And we don't have that, so these are not similar shapes. Okay. There's our first way to prove or to disprove similarity. Here's our second way. Number 2, if corresponding sides are proportional and corresponding angles are congruent, then the shapes are similar. So here's our way of describing that. Let's take a look at our first triangle. Let's label this as A, B, C, and let's call this one D, E, F. And if we want to know if these two are similar, here's what we have to prove. We'd have to say, okay, so first angles. So if, we're going to assume these are not rotated, so we're going to match up corresponding vertices. So if angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F, if we know that we have corresponding angles are congruent, and we also have to know this, we also have to verify that corresponding sides are proportional. So that means side AB divided by its corresponding side DE has to be equal to BC over EF, and that has to be equal to the ratio AC over DF. So those are our three sides. If these angles are congruent, corresponding angles are congruent, and corresponding sides are proportional, they're all the same ratio, or really what we're saying is they're all the same scale factor, then we know these two triangles are similar. Let's take a look and see how we would show that as an example question. So the question is, are these two shapes similar? They give us all kinds of measures here. Let's take a look now, class. Here is what becomes interesting. These shapes are not the same orientation, so finding which side matches up with which side can be difficult. And I'm going to show you how to do it. It's actually a pretty neat procedure. You find the biggest side on this triangle, and you're going to circle it. Then find the biggest side on this triangle and circle that. Those two sides have to correspond. Then you take the smallest side on the first triangle and you put a rectangle around it. And then you take the smallest side of the second triangle and put a rectangle around it. Those two sides correspond. And then the one that's not marked, 6.4 and 8, that's the middle size, and those two sides correspond. Alright, so that's how we set up corresponding sides. Let's check our corresponding angles first. So the first thing we're going to do is we're going to check angles. This is a little bit easier to match up because all the angles are already measured for you. We've got angle K is clearly congruent to angle D. K and D are 58 degrees. Let's take a look at angle L. That appears to be congruent to angle F. That's 32 degrees, so that's good. And angle M Is it congruent to? M is 90 and E is 90, so those are congruent. So good, our angles check out. We've got corresponding angles are congruent. Now we're going to check our sides. Okay, so notice what I showed here. When we're going to check sides, you take the two longest sides and you put a circle around them. Take the two smallest sides from each triangle and put a rectangle around them. That means we know that those match up. So let's take a look at our sides. We're going to take the large size on the first triangle, 8, and we're going to divide that by the largest size on the second triangle, which is 10. Now we're going to go back and take our smallest size. Notice, if the 8 came from the left triangle, then the 4.8 has to come from the left triangle as well. You can't flip them around. Once you begin to put the left triangle on top and the right triangle on bottom, then every other ratio has to have left triangle, right triangle, left triangle, right triangle. So 4.8 matches up with our other rectangle, which is 6. And that equals, okay, our unmarked side for our first triangle is 6.4, and that matches up with 8. All right, let's check these in our calculator. So let's do the first one. I'll just do that. 8 divided by 10 equals, it's 0.8. So this is 0.8. These all better equal each other. 4.8 divided by 6 is exactly 0.8. So far so good. And then 6.4 6.4 divided by 8 equals perfect, 0.8. So we checked corresponding sides and they are proportional. They have the same scale factor or the same ratio. So now I've got my two things. Corresponding angles show congruence. Corresponding sides show the same scale factor or proportionality. And that means I can say, yes, they are similar. Alright, so there's our second way of proving similarity. One more thing before we wrap up. If you do me a favor, class, up here in the step number 1, the description of the first way to prove two shapes are similar, will you please do me a favor and underline the word and. So in our first way of proving two shapes are similar, what I want you to do is I want you to underline the word and, which is right here. Okay, our next video is going to cover the third way that we can prove two shapes are similar.